I come to the last state, adiabatic process. In this case, we don't have an exchange of energy by heat. We don't have heat. يعني delta Q equals to O or delta Q equals to O between the initial state and the final state. No energy enters or leaves the system by heat. Q equals to O. I don't give any quantity of heat. You can do it by isolating the walls of the system. If we have an isolated wall, in this case, we cannot get any quantity of heat in or out. If delta Q equals to O, so delta E equals to minus d omega. It's very important. What I mean, if I increase the volume, so d omega is positive. We have minus, so dE is negative. So by increasing the volume, we have a negative value of internal energy. And the opposite. If I decrease the volume, so omega must be negative. We have a negative, I get a positive value of delta E, of delta U. So we have an opposite sign between delta U and omega in the case of adiabatic process. Okay? So you have to know well, in the case of a compression, I mean, if when we decrease the volume, omega must be negative, delta E must be positive. Delta E is positive, I mean we increase D. And in the case of an expansion adiabatic, omega must be positive because we increase the volume. Delta E must be negative. It's opposite. In this case, T decreases, or delta T must be also negative. What is the shape? How can we draw the adiabatic process? It's the same shape as the isothermal process, the same. But you have a very important point. Okay, let me talk first of all about this one. Initially, we are at the state, no, it's the opposite here, okay? We are here, state A, and here we have state B, okay? So the volume of A, no. Here we have A and B. Initially, at the point A, we have a small volume. I want to increase the volume. When we increase the volume without adding any quantity of heat. When we increase the volume, in this case, the pressure will decrease. You know, PV equals to nRT. If I increase the volume, P decreases. If I decrease the volume, P increases. Okay? How? By a parabolic relation between them. So here we have this relation. You know, here we don't have any constant value of PVT. To get a relation between PVT, you know, N at the initial state equals to N at the final state. So we can say N equals to PA VA divided by TA equals to the same N in the final state PB VB divided by TB. The simple relation between them. And I can tell you what is the difference between the curve of the adiabatic and the isothermal. In the case of adiabatic, the slope of the curve is very big. I mean, I go from A from the initial state to the final state with a big slope. In the case of isothermal, the slope is small, like this. Okay, for the same state. Here we have T constant, and here we have Q constant. It's very important. In the case of isothermal, the slope, the slide is slow, small. We have a small value of slope. In the case of adiabatic, we have a big value of slope, as you see here. Okay, we decrease the volume of P slowly, but not slowly, with a small slope. In the case of Q0, we have a big slope, relatively big slope. But what is the relation between PV? You know, in the case of isothermal, we have PA equals to VB, PB, VB. And in the case of V constant, we have also the relation between them. But here, I have to find a relation between PAVA, PBVB, TAVA, TBVB, and TAPA, TBPB. Unfortunately, you have to know these relations, okay? I don't give you as a given value. You have to know PAVA power gamma equals to BBVB power gamma, okay? Equals to a constant value. You know, gamma in the case of an monatomic gas equals to 3 divided by 5. In the case of diatomic equals to 5 divided by 7. What is the relation between P and V? Here between T and V, TAVA gamma minus 1 equals to TBVB gamma minus 1. Okay? The relation between T and P, TA gamma PA 1 minus gamma equals to TB gamma PB 1 minus gamma. I will solve a lot of problems. You can understand very well how can we apply these formulas and how can we calculate any term. No problem. An example, I want to find the work done during the adiabatic process. Okay, you know, d omega in the case of adiabatic process equals to P initial V initial minus P final V final divided by gamma minus 1. To find this relation, in general, you can use it directly to solve any problem, or if I ask you to find it, you have to find this relation. You have two methods to find it. First of all, you know, delta E equals to delta Q minus d omega. Okay? In the case of adiabatic, dq equals to O. So delta E equals to minus d omega. You know, dE equals to n CV delta T equals to n CV delta T equals to minus d omega. So d omega or omega equals to minus n CV T final minus T initial. Okay, equals to minus n. You know, CV equals to R divided by gamma minus 1. Okay, so here we have minus n R divided by gamma minus 1 times T final minus T initial. You know, nRT equals to P times V. So we get finally here a relation of gamma minus 1 minus times minus. We get here nRT initial. You can say P initial, V initial, minus nRT final, which is equal to minus P final, V final. So here we get the general expression of work in the case of adiabatic process. What is the second method? Now we have to use the second method. We start by d omega equals to integral of dv. You know, in the case of adiabatic process, we have a relation between P and V, where P initial, V initial, or in general, we can say P V gamma equals to constant. Okay? So we can put P here equals to K divided by V power gamma. Okay? K is constant. Here we can write the integral of this one. Okay, let me write it like this. V minus gamma dv equals to here equals to K V minus gamma plus 1 divided by minus gamma plus 1. You know, the integral of a dx, or we can say x dx equals to x1 plus 1 divided by 1 plus 1 between the limit between the initial state and the final state. Okay? So between the initial state and final state. Here equals to minus gamma plus 1. Here K, we can put it PV gamma. You know, K equals to PV gamma. You can write here K equals to PV gamma. Okay? PV gamma times V minus gamma plus 1 between the initial state and the final state, because PV gamma is a constant value. Okay, so here we have minus gamma plus 1 initial final state minus initial state. Final state, here we have P times P times V, gamma minus gamma plus 1 equals to 1. Okay, and PV. Okay, we can say between the initial state and the final state. So we get here finally P final, V final minus P initial, V initial divided by minus gamma plus 1 equals to P initial, V initial minus P final, V final divided by gamma minus 1. Okay,